Yeah.
Well, they have them spread out easily.
Like online too?
Yeah. Like, where I have 2 online classes, 3 in-person classes. There are those 3 in-person classes spread out just enough to where they all get
Well,
this class's final is...
The bright side of that is you can get in there and get them all done.
This final is special so it's on Wednesday.
I know.
Yeah, this class's final is Wednesday, December 8 a.m. to 1. Then my chemistry one, then my economics one.
Okay, so we all need to literally schedule that. I'm not even going to do it right now.
It was just the same stuff as the test plus.
Plus, yeah, I'm going to go get it. I feel like I'm dying.
Well, the first test is not a problem. This last test,
I am looking at the right one, right?
test 2.
Wait a minute. This is, where is this?
C2.
It's not even, you're just wrong? I'm wrong.
I don't know what's that.
This is the right now. So we had to do homework 9?
Yeah.
So homework 8, we're all doing homework.
With your work.
So that's the one we missed.
Yeah.
Okay, 5-2.
Yeah, it's like 1, 2, 3, 5, 6, 3, 6.
We don't have.
When we usually have homework on a test day, she picks it up.
5-2 and what?
5, 2, and 5, 3.
Well, where's the number? Start the line.
10 and 6. Yeah, I plan on doing it tonight.
10 and 6
Yeah.
on 5-2?
Yeah. They aren't hard. They're just like. And I don't know how it.
10 and 6?
Yeah, 10 for 5.2, 6 for 5.2. Yeah, we didn't cover 5.2.
Then she probably didn't.
Well, we can, probably like,
And 6 and 5.3.
because we didn't cover the chapter with the question.
Well, we had homework at 5.2, right? Number 12? Or was that just my name?
Yeah, we did. On the other side.
Oh. Well, I'll do that when I get home. Send it in. Send it in late.
Was someone like me?
It's not really absolute.
Really don't. Right now, I'm talking to classes. All of them are right now.
Get well. I did calculus too, and I tell you why. That's our number.
I mean, are we? Yeah.
So 5.2. Number 10.
That's 6/6.
So we're going straight to 6.
Yeah.
Want to see my surgery scar?
Yeah.
Scars.
What did you have done?
Half myself.
Your whole stomach?
Half of it.
Oh. Why?
Well, not even scars yet.
Yeah, I've got mine. I just got a little one in my nose. I don't know what to do.
Well, I got one piercing. It'll be removed. It's big anyway, no matter what. It would give me trouble.
I mean, sure that she'll get it.
Oh, yeah. She'll be like, hey.
Yeah, well, that's,
Because we didn't last time, didn't we?
maybe we'll just have a really intense class today.
I forgot my glasses, so I'm just, I got to put my glasses.
You know, I even think I'll leave right now. That's nice. Let's see. I think if we can hear us, we need to find all of them. Did any of you guys do the homework the other day?
That was due Monday?
Yeah.
Yeah,
Did
we
you do it? Yeah. None of us remembered to do it. We just,
I was surprised it was due Monday when we had a test.
well, that's what we were talking about. We didn't do it.
She usually doesn't.
Honestly, though, I don't know if my niece said that for so long. Every other class and we don't back.
What's your piece name?
I turned it into all day. It's like individual institution. Kind of thing.
Big boy.
It is.
Yeah.
with their education, they pay like all tuition in state schools.
Right.
We talked to my whoever said something about that about he did 30 minute lecture on that.
About how you should.
Well, he does that in the fire department.
Oh, really?
This fire department pays 85 after 4 years, and then you start at 55, and you make 85 by year 4. And then,
For firefighting?
yeah, you work every third day.
Yeah.
There's a lot of stuff he goes on and on about it.
Right.
That was my plan until I got
I
Yeah.
can't.
Air Force.
Because everything's just a blur.
I heard it's really hard to be a white male, though, when it comes to being a firefighter, because, like,
Oh, yeah.
they want women and they want people to come. So,
But
like,
she-
even if you have good test scores for a whole bunch of tests that you don't really need, but that'll bump you up, even if someone, like a woman, has a good test score but not as many tests as you have,
Yeah.
she'll still win.
I think my dad said, and it's like, fire chief with graduation. He said he was disappointed because the people. Besides that, it was like all white guys. He said he was disappointed because it doesn't represent the community they're serving.
But I see
Even
it as
though,
like,
they're
it's not
just-
the white guy's fault.
Like they
You know?
scored the highest, but
Yeah.
and then he said like, we don't need the best, we just need good enough, or something like that.
Right.
So I was like, that's a little
Great.
bit.
I was at the National Education Association student conference this summer, and
I've never.
this was the same thing.
Yeah.
I should have.
Your guys are so good for having a minority. You're the worst. And I'm like, wait, what? You want me to find more black people in the research? People have to come out.
Yeah, we just don't have.
I know.
here.
I'm like, don't be mean to me about it. It's not my fault that people
I feel like a
minorities
lot
want
of-
to teach.
Minorities don't want to teach because when they were being taught, they were being taught the way. So they don't even
Target.
think about it. Yeah,
Yes, do it. But exactly. They like to have a good experience, so like, it's not our fault.
right. They don't like school, so they don't want.
Yeah.
But I mean, like he said, thinking about it, but I don't know. A lot of white kids have good experiences in school because they have like white teachers in the
Or like
the city. You know what I mean?
Yeah, or like the dynasty thing. Teaching is the biggest dynasty.
I know what.
What do you?
I feel like I know Megan.
I have a hard time finding it.
Where they at? Where they at?
I don't know. She didn't say. She just said she was going to be married. I think because she has about that strategy.
You're probably thinking.
I wonder if his lessons before you.
Oh, definitely. Is. I'm pretty sure that's what she said.
Where you in the master.
Right.
Here and then.
Right.
Maybe not my 40s, but me, Isaiah, and Katie.
Yeah, so like you're like.
And you say,
I was in there for 2 weeks.
a little tiny small paragraph of like what we talked about and what people and she took us for time to look at the chapters to write an actual outline for it. And Katie had kind of said that she was good, but like she didn't. Like she put a line on the page. And I like, yeah, I did this. No, I need to know that too. Like, go look through your email.
I'm the creative side, so I'm like putting
I know
together.
Katie and Chris are like, we love Allie.
So all I have to do is like give me ideas, and basically summarize the book for me so we can put it all into the thing. We're done with our stuff.
Not having that. I think what we're gonna do is I thought we were supposed to have a piece of shit, but
We're supposed to be meeting with that we're not supposed to be having class.
next week I'm like,
No, we've got it. I'm
I'm sad about Isaiah. I think you would be a good.
I think so too.
And I've told him that multiple times, but
I wonder what it is specifically about education.
he just really doesn't think
Hi,
normal.
Megan. Elsa.
Here.
Morgan.
Here.
Allison.
Here.
Katie. Leah.
Here.
Catherine.
Here.
It's not.
Curtis.
Here.
All right. Sorry I was delayed by the previous class, so a few minutes late. I haven't finished the grading of everybody's, and I did graded some of the students, and we do. I think most of the students actually got the idea of the proofs, and we actually have many high scores. Curtis got 99, and Elsa got 98.5. So it looks like I guess most of the students did get the idea of the proof. If you still have trouble doing the proofs, if you don't do well in the second one, you probably need to work on the proof problems more. And I will post the grades later on Blackboard later tonight. I haven't posted grades on Blackboard yet, but I have some of you graded. Okay, if you want to check, maybe try to check the grade later by the night. And remember, final is comprehensive, so if you have trouble with the second exam, you probably still need to work on those problems that you didn't know how to do. Okay, so today we're going to be talking about chapter 6. The good thing is about chapter 6 is there will be no proof problems. Okay. I think for the rest of the semester, we won't have, I don't think we have any more proof problems. Well, I'm sorry, maybe there's one type of question. Pretty much most of them will be more like calculation type of question. There will be a little bit of, not really proof, but related to the proof, maybe a little bit different. Not really complete calculation, not complete the proof problems. Okay, so chapter 6, no proof problems. It's all more like statistics, what you learn in statistics, counting problems. And the textbook does have probability in there, but I will skip a probability part because we learned that in statistics class. It's exactly the same thing, so I'm not going to do that. So we're going to be focusing on counting problems. And many of the things you may have already learning statistics. But in statistics, we don't talk very typical counting problems, and here we're going to look at different types of counting problems. All right, so let's take a look. Chapter 6, counting problems. Okay, so we're going. I think I can give you an overview of what we will be talked about in this section. We will have a few rules. 2 rules. One is called addition rule. The other is called multiplication rule. Multiplication rule. And you will have to remember when you should use addition rule, when you should use multiplication rule. So I will give you different examples to explain to you. Sometimes students get confused, especially from the statistics class. I noticed some students get confused. When I should add, when should multiply. So there will be 2 rules. And of course, sometimes, occasionally, you will use subtraction. well, these are two basic rules. Subtraction sometimes will be used. And there will be special counting problems, special types of counting problems. So these are the rules, general method you're going to be using. But under counting problems, then we have different types. So one of them is called permutation. You may have heard that in statistics class. And the other is called combination. And you do have to be careful. The combination is different from what we usually say in real life, the combination. It has a special meaning in statistics or in discrete math. Okay, so yeah, that's pretty much what we're going to talk about in this chapter. So we're going to start with the rules. And well, by the way, permutation can be done by multiplication rule. So again, these two special types of questions will be done by you don't either use the I guess both of them are using multiplication and combination. You also have to use division there. So we're going to first explain these two rules, and then we're going to talk about the special types of counting problems. There are some problems that are going to be not special types. They're not going to be permutation, not going to be combination. But we will probably spend a lot of time talking about these two special types because they're used a lot in statistics. So let's look at these two rules, addition and multiplication. So think about the example, which is what I use in statistics class. Okay, so the main difference between addition rule and multiplication rule is depending on when you have a problem, or sometimes we call it a task or a job. We have a counting problem. Like I said, sometimes we call it a task or a job. So you are asked to select two people to do something, or select, or trying to arrange seats for the guests. So these are the jobs, tasks you have to do. And you may have many more than just one way to do it. So how many ways to do the problem? That's what the question we are being asked. So suppose we have problem number 1. I want to go to watch a movie. So notice that the biggest difference, so I want to watch a movie. Well, I'm going to just say select one movie. Select one movie. So tonight, say you only plan to watch one movie. But the other type of question, so save a little bit of space here, because I want you to compare these two questions. Problem number 2 is watch 2 movies. Select 2 movies. It could be 3 or 4, or even more. So the biggest difference is the first type of question, you only have one thing to do. After you select one movie, you're done, you're finished. But problem number 2, you're going to select 2 movies. So after you select the first movie, you still have the second step to select the second movie. Okay. All right. So let's look at the first one. So maybe you have 2 movie theaters nearby. And, well, you have the option of going to the first movie theater or the second movie theater, right? So I'm going to say 2 movie theaters. We have Theater 1, which has 3 movies available. 3 movies available tonight. And there's another theater, theater number 2, which has, say, 2 movies available. Okay, so here's the question. How many options do we have? How many ways do we have to select the one movie to watch tonight? 5, right? How did you get 5? We added 3 plus 2, which is equal to 5. So notice that the operation we used is addition, which is the rule I mentioned before. It's called addition rule. Later, when you do the question, you may not think of this as a rule, but you do need to know it's addition. You cannot do multiplication. Because when you go to, remember, we only need to select one movie. If you select one of those 3 movies from theater 1, your job is finished, right? Because we just need one movie. You select one movie, you're finished. But you have another option. you can go to movie theater 2 to select one of those 2 movies, and you are finished. Either way, when you select one from these 3 or select one from these 2, you are finished. So you are select one of them is finished. Select one of them is finished. So you're going to add them. But the second type of question, if you want to select 2 movies to watch, okay, of course you cannot watch 2 movies at the same time, right? So let's just say you're going to watch a movie from 5 o'clock to 7 o'clock. And then you're going to watch a movie from 7 o'clock to 9 o'clock. So you're going to select 2 movies. All right. Again, you still have those 2 theaters. Theater 1, it has 3 movies available tonight, and Theater 2, it has 2 movies available. Remember, with this time, you are watching 2 movies. So how many different ways to select 2 movies? How many different ways to select 2 movies? 6, right? Okay, so it's going to be 3 times 2, which is equal to 6. Well, so this time we're using multiplication. And it's called multiplication rule. So the first thing you need to make sure you understand is, okay, when do we add? When do we multiply? What's the difference? Well, over here, if you select one of the movies, is the job finished? If you select one of these movies, are we finished? No. It's just only the first step of your job, because the job now is selected 2 movies. If you're just going to select one movie from here, well, you only finished half of the job. You still have to continue, right? So that's why, so this is more like a step 1 to do a job, 3 steps, 3 options. Step 2, you have 2 options. So you're going to multiply them. So an easy tip for you to remember the difference. Well, between steps, if you have 3 ways to do the first step, 2 ways to do the second step, you will have to multiply them, okay, between steps. But go back to the first example. This is not a step 1, because this whole job only has 1 step, right? There are no 2 steps. So when you select one of these 3 movies, you're finished. You finished the job. And when you select one of these, you're finished. So these are not step 1, step 2. This is, I don't know what's the best way to call it. You can call it method 1, maybe method 2, or case 1, case 2. So maybe we can borrow what we use in proofs. So case 1, I'm going to go to movie theater 1. But when you go there, you're done. The job is finished. Case 2, I can go to the second movie theater. When you go there, your job is also finished. So between cases, you will have to add. But between steps, you're going to have to multiply. Okay. All right. Another example for multiplication rule will be, say you have 3 shirts and 2 pants, and you're going to match them. So problem, the second one, multiplication rule. So you have 3 shirts, 2 pairs of pants. When you go out, say you decide in the morning you're going to pick, of course you're going to pick a shirt and a pair of pants. How many options do you have? How many different ways to select one? So you want to select 1 shirt and 1 pair of pants. 1 pair of pants. So look, so this is the job we're going to do. Select a shirt and select a pair of pants. That's 2 steps, right? Because if you just select 1 shirt, you don't have pants, right? So you're not finished. Okay, so that's just the step 1 of the job. And this is going to be step 2 of the job. You have to select the pants. So between then, you should use multiplication, right? So how many ways do we have to select a shirt? We have 3 available. So you have 3 ways, right? And how many ways to select a pair of pants? 2, and multiply. Okay. Well, think about what we learned before in logics and statements. And, well, if it's and, means you have to do both. And usually you gotta multiply. And over here, it's or, right? So you can select the movie theater 1 or movie theater 2. So if it's or, you're gonna use plus. So there are many ways to help you to remember the differences. Let me think. Something else that you can do, I guess. If we talk about clothing, usually, of course, you have to take one shirt and one pair of pants. But let's say if you're not trying to get dressed, if you're going to the store and go shopping, you only have money to buy one piece. So you have maybe, if you want to buy another piece, you have to save enough money. So this is like the problem number 2. Now I'm going to go back to problem number 1. So you go to the store, you found out they have, you found that there are 3 shirts you like, 2 pants you like. But unfortunately, you don't have money to buy 1 shirt and 1 pants, 1 pair of pants. You only have money to buy 1 piece. Select the 1 piece, not both. So this case, how many options do you have? Buy 1 piece. 5. Right? This time you're gonna just add. If you select 1 shirt, you're done because that's all you want. And select 1 pair of pants, you're done. So you're gonna add. So because you don't have money to buy both of them, so you're gonna buy 1 shirt or 1 pair of pants. And notice that this time you're doing or. Or means you're going to do addition. Okay? If it's and, you're going to do multiplication. Okay, so is this clear to everybody? Okay. So addition rule and multiplication rule. So next we're going to look at those 2 I think we're going to start with a general question. Some practice problems of using these 2 rules. The first type of question is what we do a lot in real life. So you're asked to select a password for your account. Or even think about your social security number and your driver's license number or your license plate. So all of these, like your social security number, it has what? How many digits?
16. No, wait.
Wait.
9. 10.
8.
Sorry.
8. Wait.
No, there's 4 at the end.
Oh, yeah, 4 at the end. Okay, that's right. So that's 9, right?
Yeah, 9.
Yeah. So social security number, it has 9 digits. You're only allowed to use digits, no letters. But usually driver's license or license plate, you can use digits plus letters, right? So you have more options there. And the password, you are even allowed to use those special characters, like anything you want, like this. Sometimes they ask you, okay, one of them has to be capitalized. You must have a special character. Okay, so this is the type of question we're gonna ask, right? So have you ever wondered what? We know that any 2 people will not have the same social security number, right? So will we ever run out of the social security numbers? So that's one of the things. Everybody has to be different, right? So here's the question. How many possible social security numbers we have with 9 digits? Currently we have 9 digits. If we run out, we have to make it 10 digits, right? If the population increases. But so far it seems like we're okay. So 9 digits, how many different social security numbers could we have? So think about it. So how do we do this type of question? You can break it down into, so it's more like a 9 steps question. So first, let's pick a number for the first digit. How many options do I have?
9.
10, right? 10. 0 is allowed, right? I don't know if there's anybody's social security number is 0000000, but it's allowed, right? So the first you have from 0 to 9, 0, 1, 2, 3, all the way to 9. You have, although we have 9 digits for the social security, but the available numbers, digits we have is from 0 to 9. So you have 10 options, 10 ways to select a number for the first place. And what about the second? Still 10, right? Okay, because you're allowed to use the same digit. And the same for the third and fourth, 5, 6, 7, 8, 9. And between them, do I multiply or add? Multiply, because when you select one digit, it's just the first step. You're not done yet. So you have to continue. So between them, you're going to have to use multiplication. And it's a huge number. Usually, if you get a question like this, you can just put it as 10 to the 9. You don't have to work it out. You can use a calculator if you want, and that's going to be, actually, we can put it, it's not too bad at 9 digits. So we can put 9 zeros, right? So, okay. So it's 1 billion, right? So 1 billion. Okay. So 1 billion, I guess in the United States, we don't have 1 billion people. So that's, that's enough to cover everybody. So make sure everybody has a different search number. Okay. But, like in China, there are 1.3 or 4 billion people, and then, if they use 9 digits, that won't be enough, so they will have to use 10 or even more. Okay, so the rule we use is multiplication rule. And now let's look at a different question. What about like license plates or password? Or even if you have a safe box, you pick we usually say combination, right? But be careful, in statistics or discrete math, combination has different meaning. So we really, I shouldn't say combination here. I could say a different combination, but really combination has different meaning we will talk about later. Now, so let's look at a question we see, number 14. The type of question we're going to do is say your license plate. We have maybe 4 letters followed by 3 digits. So I can do something a little bit different. Then for 2, maybe we say, how about we have 3 letters followed by 4 digits. Okay, so how many different license plates are possible? You're allowed to use 3 letters followed by, so there's an order, followed by 4 digits. So I'm going to draw lines. So usually this helps me to break down into steps. So again, you can see that's 7 steps here. So we're going to start with the first one. The first 3 have to be letters. The last 4 have to be digits. So how many options do I have for the first letter? 26, right? Okay, 26 letters. Now, how many options are there for the second letter? Still 26 and still 26. And how many digits, how many options do I have for the first digit? 10, and still 10, and 10, and 10. And again, do we multiply them or add them? Multiply them. So you're going to get, well, you can use your calculator to get an answer. So when you take the final, you probably should bring your calculator because you're going to have to do this type of question to get an answer for that. Okay? So I'll skip that. You can use your calculator to get an answer for that. Now, okay. Well, now we're going to add some special requirements. For example, how many license plates could begin with? This is the first question. The second question, we want you to, this license plate has to begin with A and end. Thank you. And in 9. Okay, so we have some special requirements now. Previously, all the letters, all the digits, they're equally important. No, nothing special, but now, still we have to have first 3 letters and last 4 digits. But it says you must begin your license plate with the A. So how many options do I have for the first letter? 1, right? Because it has to begin with A. Now, how many options are here? 26, 26. And the last one has to be 9, so 1 option for that, right? And the other would still be 10 and 10 and 10. So usually we would like to deal with those special places or special numbers, special letters. That's a tip for you. And then you multiply them. Okay. Now then this third question is, how many, well, what if I say, well, next one is also what if I say begin with ABC? Begin with ABC. How many options are there?
3. Sure.
Ah.
Well, 1
Okay.
each.
The digits will be anything you like. The 1 for each, yes, for the letters. And digits will still be, it didn't say anything about the digits, which means you can use anything you want. So that will be 10, 10, 10, and you multiply all of them. Okay. And the next question will be, how many license plates are possible in which all the letters and digits are distinct? So previously you're allowed to use, say, if you want to have a license plate AAA, you can do that. AAA 9999. But now we have adding another restriction. You must have distinct all of the, which means you cannot have the same letter twice or same digits twice. So you must have distinct letters and distinct digits. Still, first 3 are letters, last 4 are digits. So how many options do I have for the first letter?
22.
What about second letter?
25.
Yes, because whatever you pick for the first place, if you pick the, say, X, you cannot use X anymore. You only have 25 letters available. And after that, how many are there for the third letter?
24.
4. Okay. Now digits, the first digit, we have 10 options. But after that, we have 9 and 8 and 7. And we multiply all of that numbers. All right. So that's a... okay, so that's the next question. And notice that, so some, as you can see, sometimes they say, well, no repetition allowed, like this question. No repetition is allowed. That's one thing you got to pay attention to. If no repetition is allowed distinct, you have to make sure you decrease the number of ways after each. But if they didn't say anything about that, which means you are allowed to use, so repetition, like the first question we did, repetition is allowed. Repetition is allowed. Then you can use the same thing over and over. Right. Any questions? Now let's look at another example. I guess next thing we're going to talk about is permutation. So think about a question. We're going to talk about permutation. We kind of already have it. Did something over here. So suppose I have, let's say, 5 people. And I'm going to we have 5 seats available. 5 seats in a row. So I have 1, 2, 3, 4, 5 seats. 1, 2, 3, 4, 5 seats available. So we want to arrange these 5 people to sit down. How many ways are there to arrange the seats? For the first seat, how many options do I have? Second seat, third seat, and then 2, and 2, 1, right? The last person, after you arrange, well, when you get the first person, first seat, you have 5 people there. You can pick one of them you have 5 options. And after you pick one of them and ask this person to sit down on the first seat, you only have 4 people left. So you have 4 options and 3. And when you're down to the last person, this last person has no choice, right? Has to sit down on the last seat. So we multiply then and 5 times 4 times 3 times 2 times 1, there is a short notation for that. What is that? 5 factorial, right? Okay. So we also write this as 5 factorial. If you multiply a number from all the way down to 1, each time decrease by 1, you can write it as factorial. Well, what if I have, let's say, either 5 people, 3 seats, was 3 people, 5 seats. So the next type of question possibly is I have 3 people, but I have 5 seats. How many ways to arrange these 3 people to sit down on one of those seats?
3 times 2 times 1 is 5.
Well, so this time, I guess you can focus on the people instead of focusing on the seats. So it depends on the question. If I focus on the seats, say, okay, how many ways do I have for the first seat? But there is a problem because some of the seats are going to be empty. You may not have a person. You don't have to have a person to sit on the first seat, right? So it's not good to start with the seats. So this time it would be better to start with the people. So we're going to arrange these 3 people. So the first person, how many ways are there to arrange this person to sit down? There are 5 seats there, right? So there will be 5 options for this first person. This would be a person here, not the seats anymore. And after you select a seat for this first person, and now you have how many seats are left? 4 seats left. You have 2 people, right? So the second person, this is a person. The second person, how many seats are possible for the second person? 4. And then how many seats are possible for the third person?
3.
3. So that's all, right? After you arrange these 3 people, there will be 2 seats left, but it doesn't matter. We can leave those seats empty. So you have 5 times 3 times 4. You cannot write this as factorial anymore because it doesn't go down to 1. There is a way to write it as a factorial. The textbook did give us the formula. So I can, well, you can just get, when you do the questions, you don't have to, you can just get the answer, 5 times 4, 20, so there are 60 different ways. Over here, by the way, you don't have to write it as 5 factorial, you should get an answer, 120. Okay, but usually for a proof type of question, which I'm not going to ask you to do, if you want to do the proofs, it's better to use the factorial form. So let's write down the general formula for permutation. What is the formula for a permutation? Notice we're using multiplication rule, right? Okay, so the definition says the number of R permutation, so R permutation, this is on page 315. What's called an R permutation? Of n elements. using a second example, it's kind of like this question is like doing 3 permutation. This is like 3 permutation. In this question, we can call this, this is the 3 permutation. 3 permutation of 5 elements. 5 elements. So which gives you start with the 5, you go down to 5, 4, 3, because you only have 3 people. So it's called 3 permutation. The symbol we use will be P. We use P, first letter, 5, 3. This symbol, different textbooks may have different symbols. Sometimes you see, this is what the textbook uses. Sometimes you may see P, a 5, 3 up somewhere. So there are different ways. But we're going to follow the textbook. So different ways possibly. Let me write this down here. This is how we write a P, N, comma, R. You always start the bigger number. This is the bigger one. And this one is the smaller one, or equal to. Sometimes some textbooks may use P, N, comma, R without the parentheses. Or sometimes they may just put P, R here, but N on the left. And P, R, N. So many different ways. But like I said, this is the one we're going to be using most of the time. If you learned it the other ways before and you are used to the other way, you can use the other way. But the formula says P, N, R is going to be equal to what? What do we start with? So you have 3 elements, 3 people, 5 seats. The first person has 5 options. You're going to start with N, the bigger number N. Every time you decrease by 1 and decrease by 1, you continue. When do we stop? Depending on R, depending on the number R. So in this case, when should I stop? Yeah, N minus R plus 1. How do you figure that out? So there is sort of like a pattern. If you look, you will have 3 numbers, 3 people. So you only have how many options for first person? How many options for second person? How many options for third person? So you are going to have R numbers. First person, second person, third person, and the last one will be R, right? So that if you figure out, if you look at the pattern is, so this will be your first. This will be your second person. This will be your third person, and last one, fourth person. And when you add them, N plus 1. What is N minus 1 plus 2? N minus 1 plus 2. Still going to be N plus 1, right? N minus 2 plus 3. Still plus 1. So every time it's going to be N plus 1, right? So that tells you when you should stop. So the last one is R. So how do you get N plus 1? N minus 2 plus 1. Add R. This R cancels that minus R. That gives you N plus 1, right? So notice that. So this is one way to help you to figure out, okay, what's the last one? It's going to be N minus R plus 1. When you have numbers, you know when to stop. But if you don't have numbers, you just have a letter. How do I know when I should stop? Well, you should stop at N minus R plus 1 because when you add them, it will give you N plus 1. Each time, you're going to get an N plus 1. First number plus N plus 1. Second plus N minus 1, N plus 1, N plus 1, N plus 1. So this is the formula. But this formula is so not easy to memorize, right? So that's why the textbook gives us a different formula using factorial. So we can go back to look at this example, 5 times 4 times 3. How do I write this in the factorial form? We know we can't because it doesn't go down to 1. But I can do something like this to make it go down to 1. So how about we multiply by 2 by times by 2 times by 1. But if I do that, are they still equal? No. But I can divide it by 2 by 1. After we cancel them, they're still equal, right? And why do I do that? Because the top will be exactly 5 factorial. And the bottom is exactly
2.
What factorial? 2 factorial, right? So that's what the textbook gave you, a formula for P and R. So following this example, what is P and R equal to? This long, tedious formula can be described as P of, I can use factorial format. So it's going to be 5 is the bigger number. N factorial divided by 2 is 5 minus 3, right? Okay, how do you get 2 factorial? 5 minus 3. So in this case, it will be N minus R factorial. So this is the formula given in the textbook. It's easier for you to memorize. But like I said, if you, with specific numbers, you probably can just do this. You know when to stop. All right, so that's permutation. Notice one thing. In permutation, is repetition allowed? In any permutation question, is repetition allowed? No. When you talk about people, you cannot have 2 people twice, right? You cannot have 2 copies of the same person. So permutation, one of the biggest difference from the previous question, no repetition allowed. Let's look at an example of doing, first we can evaluate, do evaluation. So how do you found the P of 7,4? How do we do P74? There are two ways to do it, right? So you can either do the long formula, which is start with the biggest number, 7, and go down by 6, and by 1 each time, by 5. When do I stop? When you have how many numbers? 4 numbers. If you have 4 numbers, then you stop, right? So think of this question like you have 4 people, 7 seats. First person, 7 options. Second person, third person, fourth person. You only have 4 people, and it's like 7 seats, 4 persons. So you will stop, and you can do that. I think 120 times 7, 840. But you can also do it by the formula, which is easier to memorize. What's the formula? The big number, 7 factorial, divided by 7 minus 4 factorial, which is 3 factorial. And then you work this out. 7 times 6 times 5, 4, 3, 2, 1, and then you do 3, 2, 1. As you can see, if you delete or cancel 3, 2, 1, you get exactly the same. Okay, so when you have specific numbers, I would say, this one is easier. But when you don't have numbers, the other way is easier. Like I said, because I'm not going to ask you to do proof problems, probably most of the time you will be in that way to do it. But if you say, I learned this way, I remember this way better, you can always use this way. Now, so next we can look at a question. Suppose I have 5 letters. Maybe we can do this. Well, let's say we have 5 B, Y, T, E, S. So we have 5 letters available. And how many ways can you choose 3 letters? Out of these 5 letters, choose 3 letters and write it in a row. To kind of make a word about, sometimes maybe it's not a real word, it doesn't have any meaning. So you're allowed to pick 3 letters out of these 5 letters. Write it in a row. So how many options, how many ways are there? So you are allowed to choose 3 letters, okay? So first letter, how many options do we have? 5 options. Second letter,
4.
4, and third letter,
3.
right? I guess you're not allowed to use the same letters, so they probably should specify distinct letters. They didn't say that, but I guess that's what we assume, that we have to use different letters here. So there will be 60. And this is exactly a permutation. It's exactly a P, 5, 3, which is equal to 60. But if you say, do I have to remember this is a permutation? I mean, you don't have to technically. And if you remember the multiplication rule, permutation is just a special case of applying multiplication rule. You can always go back to use multiplication rule. But maybe if you memorize this, for a complicated question, when you see this, oh, okay, this is the permutation P5, 3, without doing multiplication rule. Well, let's take a look at we can go back to one of the questions we did before, powers Cartesian product. But if you remember that, suppose I have A has maybe 1, 2, 3, 4, 5, 6, 7. 7 digits there, and then B has, let's say, 5, 6, 8, 9, 10. Okay. So how many elements, without listing all the elements, how many are there going to be in the Cartesian product? You don't have to list all of them. I just need to know how many are in the Cartesian product. And remember the definition? What's the Cartesian product? You pick an element from A and then pick one from B to form. There's no order, right? So you do that. So I don't need you to list all of them, like 1, 5, 1, 6, 1, 8, 1, 9. I just ask you how many elements are in here. How do you do that? 7 times 5, right? 7 times 5. Because when you form, every element here, it has two components. The first component has 7 options. Second component has 5 options. So you multiply them, that gives you 35 options. Without listing them, we should know there are 35 options. And going back to the very beginning of the semester, if you remember that we are we make a chart for 3 statements, P, Q, R. Every statement has a truth value, either true or false, right? How many different combinations do we have? Remember we did TTT, F, TFT, all that. So how many, without listing them, we should know there are how many? How many true values are there for P? Each statement is either true or false, right? So how many values are there for P?
2.
2. How many are for Q? 2, right? How many are for R? 2. And multiply them? 8, right? So you should know there should be, when you list all of them, you should have exactly 8. No more, no less. Okay, so that gives you a way to check you're not missing one where you're not having repeated something. Okay, so all of these questions that we did before, you can use counting methods to help us to determine how many ways are there. Homework question number 17 is a little, 14 should be easy. Number 30 should also be easy. Well, I can give an example for 30. The one that's a little difficult is number 17. I'm going to give you a hint before the end of the class. So we can first look at number 30. Number 36, I think you should be able to do those. So number 30. Suppose we have 5 people. 5 people. 5 people attend the theater together and sit in a row with exactly 5 seats. With 5 seats. we did the first question already. How many ways to arrange these 5 people? So which is exactly 5 times 4 times 3 times 2 times 1, 120 ways. But now we're going to add some special requirements. Suppose one of these 5 is a doctor who must sit on the aisle in case she's paged. How many ways can people be seated together in a row? Okay, so aisle seats. Which one is the aisle seats? The textbook didn't really specify very clearly. So you can assume there's only one aisle seat. Depending on the theater, if the theater is small, these 5 seats, there will be aisle seat here, aisle seat there, right? So, but you could have only one of these aisle seats. All of them are. So it depends on how you look at the question, because they didn't really specify. So I'm going to do both ways. If there's only one aisle seat, when you do the homework question, I guess you can write down what you're going to assume. If you assume there's only one aisle seat, let's say this is the aisle seat. So remember, the doctor, one of these 5 people is a doctor. And this doctor, she must sit on the aisle seat. So how many ways are there to arrange these 5 people? So this one is the aisle seat. How many ways do I have to arrange a person? 1, right? Yes. And for the rest of them, the second seat, no special requirements. So it's just going to be 4, 3, 2, and 1. And I multiply all of them. 24. But what if I have 2 aisle seats? And this is the aisle seat. And there's another aisle seat. So think about this question. So this time it's better to focus, when you have 2 aisle seats, it's better to focus on the doctor, the person. So this doctor, let's find a seat for this doctor. How many options do we have for this doctor? 2, right? The doctor can sit here or there. So for the doctor, we have 2 options. And the rest of the 4 people, so the doctor might sit here, might sit there, 2 options. But once you sit down the doctor, there are only going to be 4 seats left, and only going to be exactly 4 people. So how many ways for the rest of them? 4, 3, and 2, 1, right? 4 people, 4 seats. So that gives you 48 options. Okay, so depending on, so when you do the whole question, like I said, you probably have to specify it because they have 1 seat or 1 aisle seat or 2 aisle seats. Now, the third question is a little tricky. I guess, okay, so 5 people, we have 2 couples, 2 married couples, they want to sit together. So 2 married couples. So each couple they want to sit together with the husband on the left, with the husband on the left. Okay, so now think about how many ways do we have? How many? What? Still 5. So we have 5 seats, 5 people. But out of 5 people, there's 1 single person, but there will be 2 couples, 2 married couples. But the married couples, they want to sit together. Husband on the left, wife on the right. So how many ways are there? How do we do this question? Yes, very good. Okay. So what James said is you can group these couple as 1 person. So for example, let's say there is a husband 1 and a wife 1. Husband on the left, wife on the right. You can think of this as 1 person. Because they have to be kind of like, you can imagine that you use some kind of a string or something to tie them together. So bind them together. And then there's a second husband, the second wife. They have to be together. There's a third person, single person. So it's kind of like you arrange. So these two, you kind of sit them here, or here, or here, or there, right? Okay, and same here, or there. So we can think of the question as what? How many? We arrange 3 people. So how many ways are there to arrange 3 people? 3 times 2 times 1. Right? So there are 3 ways to arrange this, and this is like 3 factorial, so 6 ways. Okay. Does anyone have a question about this one?
Why are there only 2? Why are there only 2 ways for the second group?
Wait, say it again.
Why are there only 2 ways for the second group? Like, I thought it would be the same as the first.
Because it's like the seats. So pretty much you have 3 seats, 3 people.
Yeah.
So how many ways to you can either think of seat or the people. So how many ways to arrange the first couple? Either here or there, right?
Gotcha.
Okay. The second couple, after you arrange one of them, there will be 2 seats left.
Okay.
So over there.
Yeah.
Right?
Thank
And
you.
then, so it's sort of like you put the 2 seats together, and so if these couples sit here, and then you have to put 2 seats like together. Okay. So that's number 30. So this is a question, should help you do number 30. Like I said, no, number 36 is very easy. It's the one we did before with the letters. How many letters we can select to form, to write them in a row. Okay, the last one I want to talk about is number 17. Okay, so this question is a little tricky. So it says we have 3 officers: a president, treasurer, and a secretary. So you have a club or a committee. Well, we have, so 3 officers need to be selected, but we have 4 people. 4 people, we have Ann, Bob, Sid, and Dan. Suppose Bob is not qualified to be treasurer. So Bob cannot be treasurer. Can't be treasurer. What else? And Sid's other committees make it impossible for her to be secretary. So, can't be secretary. Now, I think that's all the restrictions we have. So how many ways can we select those 3 officers? We have 3 officers, 3 positions available. You can select from these people. Without any restriction, it would be easy. So president, you have 4 options, right? Treasurer, you have 3, and secretary, you have 2. So 4 times 3 times 2. But you cannot do that now because we have these 2 special people. Bob cannot be a treasurer, and Sid cannot be a secretary. So you have to deal with those special cases. I think what you can do is maybe you can, for a question like that, the president, treasurer, secretary, you can put available candidates here. So for president, what are the possible candidates we have? All of them, right? Ann, Bob, A, B, C, D. All of them could be. But for treasurer, remember Bob cannot be a treasurer, so we have A, C, D. For secretary, we only we have A, B, D, so possibly. But can we say, okay, 4 times 3 times 3? Can we do that? You cannot do that either, okay? Because you have to consider, if you select the A here, you cannot select A here, right? You don't have 3 options anymore, right? And you don't have 3 options here either. If you select M, you will only have C and D available here, B and D available here, right? But if you select Bob here, how many Bob to be the president? Say I select Bob to be the president. How many options do I have for the treasurer? Still 3. Still 3 here, right? I'm sorry, 2 here. It will be 2 here because Bob cannot be secretary. But if you select C to be the president, and treasurer will be 2 options, and secretary will be 3. So in every case is different. So you have to do this by cases, okay? The best way to, how many cases do I have to do? Well, you probably don't have to do all 4 cases. Because some of the cases are the same. So a hint that I'm going to give you is, so which people are special?
Bob and Sid.
Yes, so you probably can consider these 2 people. So you make, if Bob is the president, Bob or Sid to be the president. So you will have Bob, president, or president. I'm thinking maybe you can break down to 3 cases. Or case 1 and case 2 is pretty much the same, though, if you do that. So you might be able to combine case 1, case 2, into 1 case. And then the third case will be, neither of them will be the presidents. So let's say war, okay, so the other way to do the question is there are many different ways you can do. So if you do case 1, case 2, so in case 3 will be Bob, neither Bob or Sid are not president. There will be 3 cases. Or any other ways to do the problem, do cases. So that's one way to do the question. You have found how many ways are there if Bob is the president, how many ways are there if Sid is the president, how many ways are there if there are neither of them is the president. So and then after that, you will have to add them together. Trying to see, let me see if I can do a similar question. The worst case, if you say I have trouble doing cases, the worst case, list all of them. And because this question will not be too bad, okay? So you can list A, and then C, B, A, D, B, A. You can do that, but that way a little tedious, but you will still be able to work it out. Let's see, any other ways to do this question? You might be able to consider treasurer or secretary first. Say, case 1, you could make, okay, if A is the treasurer, case 2, if A is the secretary, case 3, if A is the president. So you could also do that. So again, there are many different ways you can do. The textbook does not really have, let's see if we have something a little similar. Yeah, I can do another example similar to this on page 311. So this one, the same thing. We have president, treasurer, and secretary. And cannot be the president, so which makes B, C, D for the president. Either Sid or Dan must be the secretary. So secretary only has 2 options, C or D. And the treasurer, it did not have any requirements. So we can have A, B, C, D. It's sort of similar to the homework question. Okay. Because different places have different options. Okay, so the one way you could do is list all the possibilities. To draw it, we can use the tree diagram, which we talked about in chapter 1 to do this. So we're going to start with a president. We start with a person for president. We could do either B or C or D, right? Okay. And then next step, second step, choose a person for the treasury. So if B is the president, how many possible ways for the treasurer? Let me mark it out. So because B cannot be selected again for treasurer. One person cannot take 2 positions. So you're going to have A, C, and D. And if C is the president, then C cannot be the treasurer, so you're going to have A, B, D. And if D is the president, then you cannot have D, so you're going to have A, B, C. Okay. Now, last step, choose a person for the secretary. So if B is the president, A is the treasurer, how many options do we have for secretary? 2, right? So either A or B are selected, so we have C or D here. But if C is the treasurer, then you only have D available. If D is the treasurer, you only have C available. Now, same thing here. So C is used. You cannot use C anymore, so you have D, D. And this one, C and D are both used. There's a problem. You cannot pick anybody, right? So this will be a problem. So this way of choosing C as president, D as treasurer won't work. Because you will not have anybody for the secretary, because one of them has to be the secretary. Now continue, D, A. So we have C left for secretary. We have C left for secretary. D and C are both used. So this won't work because... Okay, so now what are the options? We have BAC, BAD, BCD, BDC, CA. So you can count how many ways. 1, 2, 3, 4, 5, 6, 7, 8, right? 8 different ways. So this is like the tedious way to do it. Well, from what we just did, the way we're making the tree, you can tell that. So how about we do this? First, select the person for the secretary. So this way is possible. You can do that way. When you do the homework, if you want, you can do this way. But I could if I choose C or D as the secretary, because one of them has to be secretary, right? So you could do, say, choose C as secretary, C as secretary, C or D as secretary. How many ways? So that would be 2 ways, right? So either C or D, so there are 2 ways. But after you select C or D, so let's say C is the secretary. How many ways are left for president? If C is the secretary, president, there will be 2 ways, either B or D, right? Okay. But if B is the president, you will not be able to use B anymore, and then you will have okay. So you will have president 2 ways, and how many ways are for the treasurer? Remember, C is selected. You have to cross out C from here, and from there, if you select C, you have to cross C out. So that's why we only have two options for president. But if you choose one of those for president, either B or D, you have to cross them out from the treasurer, right? So then you will either cross out B or D. How many options are left? Still 2, right? So either cross out B or cross out D. That gives you 2 options left for the secretary. So that gives you 2 times 2 times 2, which is 8. It actually matches 1, 2, 3, 4, 5, 6, 7, 8. Okay. Well, drawing the diagram is very easy, but it's a little tedious. You don't have to think too much. But You can also do this way, like I said, C or D, right? 2 options. But for this is for the secretary, for the president, for the treasurer. After you either choose C or D, you gotta cross out. If you cross out the C, then there's 2 options left. So that's why I have 2. Even if you choose D, you cross out D, you'll still have 2 options left. And then with treasurer, doesn't matter if you C or D, then they're gone. So you only have 2 options left, A and B. So that's why you get 8 answers. Okay. All right. Any questions? I haven't had time to talk about combination today. I think I would talk about combination maybe next Wednesday. So there will be no class on Monday, right?
Correct.
Okay.
Right.
So the homework will be due. This homework will be due next Wednesday. Okay.
Was,
And I will. Yes.
was homework number 10 due Monday? Because I thought the syllabus said it was due tonight.
Well, actually, I wanted you, but it's okay. So if you thought it was today, you can turn it in today. So I won't come too late. Do you have any trouble doing any of those 2 problems? Hopefully after the review. Okay, you can turn in today. So I know some of you probably thought it was today, but actually it was due on Monday. But that's okay. So I won't count it as late if you turn in today. Any other question? Okay, that's all for today.
Water in here. God, it's supposed to snow tomorrow.
Yeah.
I know. And then on Friday, it's not really supposed to warm up. So it's going to I mean, it's only like above 15 today rather than
Yes.
Saturday, I think it's still supposed to be warm, but anyway, it's supposed to be like only a high of 43. So,
Well, today's high is
53.
Yes.
You know, but it doesn't feel like, it's cold. It's going to be all of this.
Oh, wait. So,
cold.
That'd be a horrible time, yeah.
I think it gives you. I believe this is a new policy.
It's still a fun packet thing.
Some out of students.
Coolers in the bag.
Oh
Kristen, they looked at the DARS. They don't have that option. They didn't say we do. You do. So it's the new student.
We had Martha and
Yes. So did you check?
My God.
That's safe for this one. That's good. So we don't have her. Not this coming.
Why is it so long?
But I'm going to teach most of you going to take the ingredients.
That's really funny. On my big study. What?
Oh, I'm not expecting that until Monday.
Actually,
I know, that's the way you're showing.
you don't have class at all. So which means 36. All right. Hopefully. Okay. We're yeah.
Your meeting has ended.